Hello learners. Today we are going to solve a classic case of logistic regression which was taught to me at IIM Bangalore. It was taught by Dr. U. Dinesh Kumar sir. It is a case of micro mortgage analytics. The case depicted that 90% of the people work on unorganized sector and they have a dream to buy a house. They don't have a documentation because they are not working in a formal organization. They don't have their salary slip. They don't have even bank account or pan card, or they don't file IT return, and due to these reasons their loan gets rejected. And they have also discussed about a imagination of a Kiryana store owner where he has monthly income of 30 to 40,000. He has savings of 5 to 6 lakhs, but lack of above mentioned document, his loan gets rejected. And not only that much, there are 21 million such cases. So the solution was Shubham Housing Finance. It was one of the micro mortgage finance company. It works under Roji Awas Yojana and tries to fund the loan to unorganized sector. They provide loan to such kind of people. Here, Subham Finance has to check the credibility of applicant, and it has some cost to pay, the verification cost. So yes, I have made the process very simple. If any application comes to the bank, they have to first do the documentation. After that, there would be a branch verification where from branch they will do a cross check to with reference and so on. There would be a field verification, and on the basis of field verification, the decision is taken whether to give loan or to reject loan. So here in this case, 1 would be approving the loan, 0 is rejecting the loan. So this way whole process goes on. Now, what is actual business problem? So, yes, as I said, the cost of whole process is 8,000. So, can we build a model which can give us a decision at initial stage of verification? Here, in our case, the y variable is a factor, or you can say a categorical variable, where y is equal to 1 means loan approved and y is equal to 0 means it gets rejected. So, when our dependent variable is factor or a categorical variable, the most suitable fit is logistic regression. So now I am giving a basic information of logistic regression. So logistic regression actually tries to find a class probability where we will try to find the probability of p is equal to y, p of y is equal to 1, and we will also work on finding the probability of p of y is equal to 0. Always remember, when we are applying logistic regression, we find the probability, and on the basis of it, it will help us to take the decision. There are certain things we need to understand here. uh, Many times no, in regression we have learned that the error should be normally distributed, but in logistic regression it may or it may not follow that rule. And yes, there is one logit function. It tries to convert, like it is the log function. It tries to convert our formula, and it is trying to give us in our linear equation. We will see all this thing. So yes, I will use blue sky statistics to solve this problem. So let's start with blue sky statistics. So basically this is a blue sky statistics. I am just loading the data. So first we need to click on open. We will select the data file. Obviously here we need training data. So now it's like SPSS only. We have data view and variable view. So I will check the variable view. Yes, here decision by default it has taken integer because 0 and 1 is also a number. So I have to change and I have to make a factor. You can see here it has said it is a grid edit. Here also you got 0 and 1. Now you can see this is my data. These are all variable. First, I will run logistic regression with one variable. I will take dependent variable as a decision, and independent variable as LTV. I will explain what is LTV. First, we will run the model. So click on model fitting, click on regression. You can see here logistic basic. Just click on it. Very simple. First, decision is our dependent variable. Just drag it to it. Moving towards LTV. Now I will explain what is LTV. So it's loan to asset value. In simple terms, it's the ratio of loan to asset value. So here just click play button. So you will get your output of regression. Very simple, very basic software. Now what is loan to asset value? Now suppose if I want to buy a house of 10 lakh. So asset is of 10 lakh and I am paying down payment of 5 lakh and I am taking loan of 5 lakh. So yes, the asset value, the mortgage of asset value is more compared to loan value. Now suppose if I am changing the ratio of it, I am taking house of 10 lakh and I am only paying 2 lakh as a down payment and 8 lakh as a loan. So now here the chances of the loan get reduced. Now we will see this in this format also. So yes, this is our basic output. Here alpha plus beta x, x is our LTV. So yes, alpha or constant is 3.1819 and your beta is minus 0.03. So it is negative relationship. We will see that. And this is basic my coefficient. I will talk about null events on when we will solve multiple regression. So now this is my important part. Here I will just use copy. I will paste it to regression to Excel. So this is basic output. I will just zoom it so you can see it clearly. Now here I will try to make two or three column, that is beta 0, beta 1, LTV, that is our x variable. I will make z. I will make estimate exponential z. I will then write p is equal p of x is equal to 1 and p of x is equal to 0. I will find all the probability. Now I am just entering all the formulas. Okay, so beta 0 and beta 1 is this. I am just copying. I am pasting as text or numbers. Now here LTV. Suppose as I have given the first example that I am taking loan of 10 lakh. I am paying 5 lakh as a down payment and I am taking loan of 5 lakh. So asset to loan ratio is 0.50. So I will write 50% here. Now I wanted to find Z. So always remember Z is equal to this, that is beta 0 plus beta 1 into your LTV. Now find out exponential Z. So just give enter. Now if you want probability of 1, so just write down equal to this value, divide it by bracket 1 plus again the same exponential Z value. You will find 84% chances of approval if you have 50% of LTV. Now I want, you can say, reverse scenario, rejection ratio. So I will just write 1 minus this value. So it's 15% chances of rejection if I have LTV ratio of 50. Now suppose if I am increasing the ratio, I am taking 80% as a ratio. You can see here the change is like the loan acceptance chance becomes 68% and rejection chance is slightly higher. Now suppose if I am changing the scenario, I have asset of 10 lakh and I want loan of 12 lakh. So I am just giving 120%. So you can see here it is less than zero point 0.5. You can say it's 0.40. So rejection chances are nearly 60% and acceptance chances are 40%. So you can see this way this regression model helps us to take the decision. So this is only one variable. Now let's take all variable and solve the problem. So here again I am going to blue sky statistics. I am again going towards same model, that is regression, again logistic basic regression. Here again decision variable is my dependent variable is my decision. I will select all the variables. All the numerical variables would be selected except E type. E type actually is repeated twice, so I will not take it. Marital status. See here employee 1, 2, 3 or employee type 1, 2, 3 and E type both are there. So I am taking this. Education class I am taking. All numerical variables I am taking it. Old EMI, all the numerical variables are selected. Now you can see here all the variables are selected. Again the same plot and all that I am just adding it. Just giving a play button. The beautiful output will come. It's running the regression model. It will take time as per your processor. So now I think my answer has came. So you can see this much big because I have taken all the variables and more, not all the variables would be significant, but yes, you can see all the variables are considered and I have the summary of it. So now I want a significant variables, like see many of them are not significant. So this is basically I'm showing it the p-value of all the variables. So you can see many of the variables are not significant. Okay, it's just give me more one more time. Yes, many of them are not significant because it is more than 0.05. So here I am trying to like work more on model. So I am just going on model evaluation. I am going towards stepwise regression and I will just select forward and I will also work with BIC. See, always remember AIC gives 2 penalty whereas BIC gives 5 penalty and many of the statistics prefers BIC more than AIC. So I will just play. You can see now all the variables would be significant and that variables would be taken care by us. So yes, this output is ready. Now I will directly go to last table. So these are the variables that are more significant for my study. Now, actually, what it has done and what is the concept of null deviance? So, remember, whenever I add or reduce the variables, I try to see the null deviance. If null deviance is becoming lower and lower, it is more beneficial for me. In simple terms, what is null deviance? Like it is a deviation from exact model, how far we are. Like you can see here, the null deviations are decreasing by adding or removing the variable. So it's a kind of a try and error model. And last null deviance was nearly 1574. And more important, uh, all the variables are significant here, so this model is considered a fit model for analysis. So I am just copying it in our Excel file. I'm writing here MLM. So I am just pasting here this model. I'm again zooming it so it can be visible. So most of the values are, you can say it's accepted, or you can say it's this significant variables are there because p value is less than 0.05. Okay, now we are moving towards one more analysis, that whether if I am applying this model, what would be, how can I predict it? How can I apply this model? So go to predict, go to model scoring. Yes, always remember here you have to select our model. Here you have to just generate confusion matrix and confidence interval. Here you have to give name of it. So I will just give predicted values. Yes, I will always predict positive like 1 because I want prediction or probability for approval of loan. I will also click on ROC table and ROC values. I will then click play button. It will take some time because it is generating large data for us. So this way you can work on logistic model. Just wait 1 or 2 minutes. It will generate whole output. Yes, you can see here this is my confusion matrix. So I will just click copy and paste it in my Excel. So what it predicts, that this is my prediction and this is my actual output. So my model predicted and loan approved is 1203. My model predicted but rejected is 179. My model rejected, the prediction was rejected, but model actually have approved is 52. So this is a deadliest case. The model says we should not give the loan to them, but yes, we are actually giving it. And this is basically a fine thing. Like it's like if model is also saying and we are also rejecting. So this both scenario is good. So I am highlighting this both as a green scenario, and this is also a green scenario, but this both are not acceptable scenario. So obviously I will highlight it with red because these are error. This is error. So we try to reduce the error. I will teach you how to work on it. But yes, this is our confusion matrix, and this way we can find out the best output. Now there is more important concept, sensitivity and all that. So I will just go to PPT, and yes, this, as I have shown you, this is my confusion matrix, where if my model predicts correct and if model is correct, applied correct, it is true positive scenario. But if model is rejecting and also my actual model rejects, its true negative scenario. But these both are deadly, like false negative and false positive. Now, there is something known as ROC curve. It is known as receiving operating curve. Actually, it was used in World War II to detect the underwater signals received from enemy submarines. It has two important aspects, that is specificity and sensitivity. Now we will learn this both. What is specificity? So as I have shown you the model, specificity means true negative divide by true negative plus false positive. And sensitivity means true positive divide by true positive plus false negative. So this both are ratio, and yes, this all things are in our output. So you can see here there is specificity, sensitivity, all these statistics are with us. And this is, I cannot zoom here, but I think you can see it. Otherwise, I am copying this and I am pasting to our Excel so I can show you. So you can see here, these are the values that are given by our model. Yes, our specificity is 95%. Sorry, sensitivity is 95%. Specificity is 0.43. And this both are important to take the decision. But again, as I always say, we have to go beyond the statistics. So I will also see the ROC table. So you can just, this is a very important table. This is ROC table. It is very long table. I will show you. I will just copy it first. It will take much more time. This is ROC table. Again, the full form, as I always say, receiver operating curve. It's very important. I will show you how it looks like, but just let it copy. It will take some time because it's large table. Once we will get this table, you will see how it works. Yes, it has copied. Now I am pasting it to our Excel new sheet. So here you can see how large the table is. Yes, you can see here this much large the table is, nearly 1573 cells. So now this is known as our ROC table, and these are the probability, this is specificity. Now here most important thing is we have to see this Yohn's index, Udinese index, and this helps us to get the best cutoff point. So here if I just try to select this whole, and if I just try to arrange from largest to smallest, I get this a best cutoff point. This is actually best cutoff point. I will just zoom it so you can get idea. And this is like output of a you can say table. So here we can find this as a best cutoff point. Now, how we got, or what is Yon's index or Udeni's index? So I will just go here. This is Udeni's index, where they take true positive divide by true positive plus false negative plus true negative divide by true negative plus false positive whole minus 1. So this way you can get optimal cutoff. So it's a very formula based thing, but yes, always remember, when you try to arrange it, it should be from maximum to minimum. So you will find this stars also. So this is a best cutoff point. But here there is one problem with Udini's index. Yes, the first problem is it gives equal weightage to sensitivity and specificity. So it gives equal weightage to sensitivity and specificity. In other words, you can say that if I just go here, it will give equal weightage to this both ratio, like false negative and you can say this both red highlighted area. So I, as a banker, it's not feasible for me. So there is also one optimal ratio here. So yes, I can try by giving a penalty and select a feasible model. So suppose this both are my red area that I have highlighted, and I always say that false positive is okay, but false negative is not okay. So I am changing it to give penalty. So I will just delete this. I am giving penalty here, and the penalty ratio would be like I will give false positive 1 penalty plus false negative 10 penalty. Okay, so here I am giving a penalty to both of them, but yes, false positive is having less penalty, whereas false negative has a higher penalty. And if I just drag down and I just try to arrange it from lower to higher, in other words, smallest to highest, largest. Yes, this is the optimal cutoff for me. This is considered as optimal cutoff for me for getting the best result of the model. So this much you have to work and select the best model. But suppose if I don't want to work this much and I just want to identify from a blue state statistics. So yes, as I have said, uh, you just check to the data view and just go to last cell which has added new cell with probability. I will just drag from here. You can see here the last column has actually created a probability decision and decision whether to give loan or not. Here its cutoff point is again 0.50%. So if your probability is above zero point 0.5, it will give loan approval, but if your probability goes below zero point 0.5, it will reject your loan application. So this much was there in our case. I will just show you the reading material of the case also. This is the same case written by Jitendra sir, Naveen sir, Shweta ma'am, and Dinesh Kumar sir. It's the same case which I have solved. You can read it. I will attach the PDF with it. Thank you, students. Have a nice day.